Dear students, today we will learn about interrupts in Arduino microcontroller. Interrupts actually stop the current work of Arduino such that some other work can be done. Let me give you an example. Suppose that you are sitting at home chatting with someone, suddenly the telephone rings. You stop chatting and pick up the telephone to skip to the caller. When you have finished your telephonic conversation, you go back to chatting with the person before the telephone rang. So similarly, when you write an interrupt function into the Arduino microcontroller, there are certain things that are written in the while loop that the Arduino will continuously execute. But when a certain interrupt, like it may be a hardware interrupt, some change of state on the pin, or maybe a software interrupt like the timer has overflown or the timer has started, so these interrupt will interrupt the execution of the code that is written in the while loop, and whatever written in the interrupt service routine or that interrupt is bound to the any function that will be executed. So when an interrupt occurs, the controller will start to execute the interrupt service routine, or if you attach a function with the customized function, user defined function with the interrupt, that on occurrence of that interrupt, that particular function will be executed. So interrupt can come from various sources. It can be from a hardware, it can be from a software interrupt. So if you want to attach an interrupt with a pin on the microcontroller, let's say what we want to do, we are going to study the interrupts. What we want to do is that the Arduino MCU print any word on the serial monitor, and when an interrupt occur on the pin number 2 of the Arduino, then it should print on serial monitor that interrupt that the Arduino is interrupted. Now for writing the interrupt or attaching the interrupt with the pin, we have the function named as attachInterrupt, and then in the attachInterrupt we can pass 3 parameters. The number 1, the pin to which interrupt is attached. So in our case we want to attach it on the pin number 2, so we will write digitalPinToInterrupt, and in the digitalPinToInterrupt function we will write the pin number, or you can pass a variable in which you have stored the pin. So in this way we have attached an interrupt on the pin. Let's say in our case it's pin 2, we will write over here pin 2. So we have attached an interrupt on the pin 2, and what if it will do when an interrupt occur on this pin? It will call the function named as blink. Over here you can see that I have also defined a function blink. So when an interrupt occur at pin number 2, it will call the function blink. So there are 3 types of interrupt detection on the pin. The number 1 is the low. I can write over here. The number 1 is low or change or falling. So these, when you write low in at this place in the third parameter, in pass third parameter low to this function attach interrupt, then the interrupt will be triggered whenever this pin number 2 goes to low, or when this pin number is low, then the blink function will be called. If you write over here change, then what will happen, that interrupt will be triggered when the pin changes its value. And if you write falling, then it will be, if you write over here falling, then this pin when goes from high to low, then the interrupt will occur and blink function will be called. So let's test this. I write over here that if there is a change on this pin, then this blink function will be called. So let me just comment this. Let me save this. Now how you will write this into your code? First of all, I have declared a variable pin data type int and return 2, and over here I have attached an interrupt on pin number 2, and this interrupt will be called when there is a change on the pin number 2. And when this interrupt occurs, then this interrupt will call the function blink, and when this function blink is called, then in the blink function it will print print on the serial monitor that interrupt called, or we can change it over here interrupt has, or we can write occurred. So we remove this, okay, and in this we can write running. So let's save this. Now what will happen, on the right side you can see over here I have attached with the pin number 2 a button, and button is attached with the 5 volt, and whenever I press this button 5 volt will reach over here on the pin number 2, and by default it's pulled down, and over here you will get 0 volt on the pin number 2. Now what will happen, that when I execute the code, then the microcontroller will run the setup. As you know, that's why setup is executed once, and will attach the interrupt at pin number 2, and then it will go into while loop, and it will continuously start printing running, and whenever I press this button, then interrupt function will be called blink, and it will print the interrupt occurred. So let's test this. Let me run this function over run the code, and you can see over here it's writing running, and this is because it's executing over here in the while loop. And when I press this button over here, you can see interrupt is called. Okay, now why you are not able to see this, because there we haven't added any delay function. So let me add over here delay, a delay of 500 millisecond. Let me save this so that we can visualize. Let me stop, run this again. Now it's in the while loop. When I click over here, you can see that interrupt occurred. So when I press the button, interrupt occurred. So over here in this way, now you see over here running, it's running, executing this code, and when I click on this, interrupt occurred, and the serial monitor prints the interrupt occurred on the serial monitor. So over here you see that when I press this button, you see that multiple times interrupt occurred is printed on the serial monitor, because I haven't added the time delay for bouncing and debouncing. So for that, let me add over here into this code over here, I write in this function to validate if the interrupt is valid or not. So for that we have to add bouncing and debounce time. For that, let's say I declare a variable unsigned long and I write no equal to millis. This millis function will check the time for which the microcontroller is running, and then if now minus last interrupt time, okay, I write over here last interrupt time greater than 50, then what will happen? I have written the code over here. Let me just copy and let's add the code over here. So what I have done over here, I have added the debounce time over here, the 50 millisecond. This will check if the interrupt that is occurred is valid or not. It actually adds a delay when the interrupt has occurred, and after that interrupt has occurred, it will wait for a time. If that time is complete, then it will confirm and interrupt occurred will be true, and if interrupt occurred is true, it will print on the serial monitor that interrupt called. So there are few variables to define. Let me add the variables, global variables over here. Let me save this and let's